Mass black holes born from dying stars. They are cosmic behemoths, millions to billions of times the mass of our Sun, packed into a space smaller than our solar system. For more than half a century, one of the biggest questions in astrophysics has haunted scientists. Does every galaxy have a supermassive black hole at its center? Today, we are going to unravel this mystery, using data from NASA, the Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories, to reveal the truth behind these invisible giants and their unbreakable link to galaxy formation. Let us start with the basics. A black hole is a region in space where gravity is so strong that nothing, not even light, can escape its pull. Stellar mass black holes are common formed when a massive star runs out of fuel and collapses under its own weight. But supermassive black holes are on an entirely different scale. The one at the center of our Milky Way galaxy, called Sagittarius A multiplied by, or SCR A multiplied by, is about 4.3 million times the mass of the Sun, and sits just 26,000 light-years from Earth. For years, astronomers could only detect it by observing the orbits of stars speeding around an invisible massive object at the galactic center. In 2022, the Event Horizon Telescope captured the first direct image of SGR, A multiplied by, proving its existence beyond a doubt and giving us our first real look at the heart of our home galaxy. This incredible achievement was not the work of a single telescope, but a global network of 8 radio observatories spread across the planet, working together as a single, Earth-sized, virtual telescope. Scientists synchronized atomic clocks to within a billionth of a second to collect data piercing through the thick dust and gas that shroud the galactic center. For years, researchers processed petabytes of information to create that iconic image, turning invisible radio waves into a visual portrait of a black hole that had haunted human imagination for a century. This breakthrough didn't just confirm SGR, A multiplied by, it opened a new window to study supermassive black holes in every corner of the cosmos. For decades, observations of large galaxies, spiral galaxies like the Milky Way, elliptical galaxies that are round and densely packed, and lenticular galaxies that blend the two, all pointed to the same pattern. Every large galaxy has a supermassive black hole at its core. Astronomers found this correlation by measuring the mass of the black hole and comparing it to the mass of the galaxy's central bulge, the tight cluster of stars at the center. The bigger the bulge, the bigger the black hole. This relationship, known as the M-sigma relation, became a cornerstone of galactic astronomy, leading scientists to believe that supermassive black holes are not just passengers in galaxies, they are drivers of their growth and evolution. But why would this connection exist? The leading theory is that black holes and galaxies grow together. When the universe was young, just a few 100 million years after the Big Bang, the first clouds of gas collapsed to form the first stars and the first small black holes. These black holes fed on surrounding gas and dust, growing larger over time, while the gas around them formed stars and built the structure of the galaxy. As the galaxy expanded and merged with other small galaxies, the black holes at their centers merged too, growing more massive with each collision. This co-evolution means that a galaxy cannot reach a large size without a supermassive black hole to anchor it, regulating the flow of gas and triggering star formation across the galactic disk. NASA's Chandra X-ray Observatory has played a critical role in proving this link. X-rays are emitted by the hot gas, spiraling into a black hole's accretion disk, the bright ring of material that surrounds the event horizon. Chandra has detected these X-ray signals in thousands of large galaxies, confirming that a supermassive black hole is present and active at their centers. The James Webb Space Telescope, launched in 2021, has taken this research even further, peering back to the earliest galaxies in the universe, just 300 million years after the Big Bang. Webb has found supermassive black holes in these primitive galaxies, some already billions of times the Sun's mass, showing that these giants formed much faster than scientists once thought, and were present from the very beginning of cosmic history. But the question remains, does every galaxy have one? The answer is no, and the exceptions lie in the smallest galaxies in the universe, dwarf galaxies. Dwarf galaxies are tiny, faint systems that contain just a few million to a few billion stars, compared to the hundreds of billions in the Milky Way. For years, astronomers struggled to find supermassive black holes in these small galaxies, and for good reason. Dwarf galaxies do not have a large central bulge of stars, the structure that is tightly linked to supermassive black holes in larger systems. Many dwarf galaxies are also dark matter dominated, meaning Most of their mass is made of invisible dark matter, not stars or gas, leaving little material for a black hole to feed on and grow. Some dwarf galaxies do have small black holes, but these are not supermassive. They are intermediate mass black holes, hundreds to thousands of times the Sun's mass, far smaller than the giants in large galaxies. A 2023 study using Hubble and Webb data found that only about 10% of dwarf galaxies host a black hole of any significant size, and none have been found with a true supermassive black hole. This tells us that the m-sigma relation, which holds for large galaxies, breaks down for small ones. Dwarf galaxies never grew large enough to merge with other systems and build a supermassive black hole, and their low gas content means they cannot feed a black hole to supermassive proportions. There are also rare large galaxies that seem to lack a supermassive black hole, though these are extremely uncommon. One example is NGC 1277A, lenticular galaxy, about 220 million light-years away. For years, astronomers thought NGC 1277 had an unusually small black hole, but recent observations suggest it may have no central black hole at all. This galaxy is a relic from the early universe, a fossil galaxy that stopped forming stars and merging with other systems billions of years ago. Without mergers to fuel its growth, its black hole never formed or was ejected during a past galactic collision. Cases like NGC 1277 are exceptions that prove the rule. Supermassive black holes are universal in large evolving galaxies, but not in every galaxy across the cosmos. So, what does this mean for our understanding of the universe? It means supermassive black holes are not just random cosmic objects. They are essential to the life cycle of large galaxies. They shape star formation, regulate the flow of gas, and even influence the shape and structure of the galaxy itself. Without a supermassive black hole at its center, a large galaxy would not exist as we know it. Dwarf galaxies, on the other hand, are cosmic leftovers, small systems that never underwent the growth and mergers needed to create a supermassive black hole. They are quiet, faint, and free of the giant black holes that dominate their larger cousins. As technology advances, astronomers will keep searching for more clues. The Nancy Grace Roman Space Telescope, set to launch in the 2020s, will map millions of galaxies and hunt for black holes in even the faintest dwarf systems. We will learn more about how black holes form in the early universe, how they merge, and why some galaxies never develop them. Every new discovery brings us closer to understanding the fundamental rules that govern the cosmos, from the smallest stars to the largest black holes. The universe is full of mysteries, but the link between supermassive black holes and large galaxies is one we are finally beginning to solve. Every spiral galaxy, every elliptical galaxy, every bright, massive system that lights up the cosmos has a supermassive black hole at its heart. Dwarf galaxies and rare fossil galaxies are the only exceptions, tiny outliers in a universe built on the partnership between galaxies and their invisible, massive anchors. The next time you look at a galaxy, remember, you are not just seeing stars and gas, you are seeing a cosmic giant, hidden in the dark, holding it all together. Please like, comment, share, and subscribe to the channel.